Leetcode problem 1100. Find k-length substrings with no repeated characters. So we are giving a string s and an integer k. So we're going to return the number of substrings in s of less k with no repeated characters. So what does that mean? So for example, for the first one, have with this f, so the length is going to be 5 and there's no repeated characters. So this is one valid count. So for this example, because k equal to 5 and the length of the string is only 4, so that means it's not possible, so it's going to be 0. Yeah. So let's just count how many of them. So here to f, it's going to be 1, and then from a to u, it's going to be another 1. So I don't want to count it because there are so many characters, but the meaning is we just need to find how many of them. Yeah. So we're going to use a sliding window to solve the problem because this s and k, both of them equal to 10 to the power 5, and s consists of only lowercase letters. So this means basically we can check the k. Yeah. So if this k is more than 26, so definitely it's not possible. Yeah. So it's going to be a false. Now we're going to use a sliding window to check the problem. So we're going to prepare the final result and a pointer L and a counter C. So the result and L going to be 0, 0, and C going to be a counter. So let me just use a dictionary D instead of C, yeah, as the counter. So now I'm going to loop through 8. So for I, C, enumerate the string S. First of all, I'm going to update the counter. So the counter going to plus equal to 1. Now I'm going to check the counter. So while yeah, this character's count is more than 1, definitely that means impossible. So basically I'm going to update the L pointer, and finally I'm going to check if r minus L plus 1. If this is more than or equal to k, I'm going to update the result. Finally I'm going to return the result. So this is the basic pattern, but how can we deal with these areas? So if this is more than 1, I will slide my window. If I were to slide the window, what am I going to do? I'm going to check, I'm going to update it by using the dictionary of SL, gonna minus equal to 1. So I'm going to update this character. So for example, here, this one, okay? Yeah. So now, I will not do anything because it is always be unique characters. So I'm going to update the result. Now I will go to another one U. I will update the result. I will go to N, so it is always unique. I will update the result. Now it goes to O. So all those characters are unique. So I'm gonna update the result. Now I will go to N. So the count of this N gonna be 2. So this means I'm gonna slide my window. So I'm gonna slide until here. So it means I'm gonna slide in from this O from here, and then I'm gonna continue to count. Now I find this E, it is okay. Now I find another E, so this means there's gonna be a duplicate. Yeah. So I'm gonna slide my window to here, and then I'm continue to count. Yeah. So this is the basic idea of how we'll count it. Yeah. Maybe we can try this example, although it is too long, but it's okay. So let's just loop through it. So this have. To F there's a 1, to U there's another 1, and to N there's another 1, right? To O there's another 1, yeah. And then to N, as there is a duplicate, so DC is going to be more than 1. So we're going to slide the left side, so to A, to B, until to this N, so there's still 2, until to this O. So the DC is going to become 1. Instead of 2, so now it is okay. But we're going to check the r minus L plus 1. If it is more than 5, we're going to update it. But currently, this O and N, it is not more than 5. So currently, we are starting from this O. This is the L pointer, and our R pointer is at N. Now our R pointer going to go to L, go to E. Yeah, it is okay. Now I'm going to this E. This is not okay, definitely. So what I'm going to do? I'm going to update the left border. I'm going to check. So because there is a duplicate, so the left border going to update to this E. And then I'm going to continue this T, this C, this O, this D. So it means there's another one. So I'm going to update it. Yeah. And then what I'm going to do? Yeah, I just want to continue. Yeah, because it is always unique. and the R pointer will be here. But now I have a duplicate of E, and I will shift the L pointer to here. Now I don't have the duplicate because it's TCODE, so I'm gonna plus another one. So in total, it's gonna be 6. So this is exactly loop through of the sliding window. So for you can just simulate it like that. But basically, this is the coding what we're gonna do to solve the problem. Yeah. Now let me just run it. There's something wrong with this R. I didn't prepare. Oh, here. Let me just use R instead of I. Yeah, now as you can see it works. Now let me just submit it to tag. Yeah, this is a string. I didn't expect that because I needed to return 0 instead of false, because if I didn't find it, it's going to be 0 instead of false. Now it should be okay. Now let me just run it and submit it to tag if I can pause. Now as you can see, I paused for testing cases and it's pretty fast and the code is really clean. And maybe you're gonna think, do we need to have this kind of tag? Basically, if we do not tag, is that okay? Yeah, we can still do it. We just run the loop for one time. Basically, it is on time. It doesn't matter. So we will still use it, right? Because yeah, why we need to tag that? Anyway, we can pass it. Yeah, so I will delete that. Yeah, but in some testing cases, if they just prepare some testing cases to control this case. Basically, you need to have a tag to speed up, to speed up your coding. But for this one, I don't think that is necessary. Yeah, even though maybe this case is 100 or 1000, but it doesn't matter. We just loop through once. Or maybe for someone you would like to write it like this because maybe you think this is better. It is still okay. Yeah. So it is still okay. Maybe this is better. Yeah, it depended on you. I think that's all for it. Thank you for watching. See you next time.